Greetings. Today I will be presenting a Master Engineering Management project focused on production risk mitigation and cost reduction through the replacement of a unity gain buffer OPAN using our motor self-starter control board. So this project addressed three business priorities. We have yield improvement, life cycle risk due to the coming end of life of the part. Then we have material cost reduction, and all this will be maintaining all the electrical performance and footprint compatibility. So I will walk through business and technical background, current performance, and financial impact. It will be like project objective, also the DFSS methodology, and the timeline to production and cost and business impact over here. So over here, a little bit of background is like information. So we have the electronic business. So electronic is like a high volume motor software start manufacturing. So over here, we're looking like a revenue critical for the product line. We're looking at sell risk. So the life cycle and supply risk that we see over here. So we have the current OPAN that is going to be going end of life by 2027. So this is used in several assemblies for the soft starters. So we have X711 and the E511. So in those PCBAs we have those. So the annual usage is like 138K units per year, and the life cycle is 5 years versus 9 years. So this is the replacement. We're looking at 9 years improvement. Over this project also, there is like a cost out opportunity, a VAV. So we have a replacement identified that is lower price and could be expecting us to get like a 70K in that amount. We have quality gaps. So the current one have a lower accuracy. So we experience a higher percent of errors in temperature and current. So it's around 7% of errors between those two. And looking at the technical role, we have an OPAN that it is used in the system as a unit gain buffer. We can see it over here in the OPAN that where it's used. I need to for confidential, I put some background notes over there to block some of the design. But these we need to be able to meet the CTQ and footprint compatibles. It's part of the technical portion of it. So the performance and financial situation. So we perform a process capability analysis on the sensing error. Both current and temperature channels show like low capability with error ratings around like 7% outside of spec. And from a cost perspective, we have that the current OPAN costs like $1.37, and the proposed replacement is like 0.352 cents. So that is like 3.89 per unit cost reduction. So we're looking at a really good VAV project here also, in addition to mitigating the risk. And we have 70K per year savings before considering all the COPQ reduction from yield improvement that we also going to have and from customer complaints. So we have quality, cost, and life cycles drivers all aligned for this Master Engineering Management project. So this project has 4 primary objectives. We have validation. Over here we'll be completing electrical validation and a pilot build to confirm performance. We have quality. So reduce sensing defects from 7% to 2%. And also we have continuity. So over here we're gonna be having the release, the replacement before the current device reach end of life. That's the way we're going to be ensuring that the business can keep going through the next years without having a sale risk or like this material risk that we're looking right now. For the cost, we need to achieve more than 50K annual savings. With the current estimates, we are looking around like 70K. So looking at these savings and costs, we're looking at PCB redesign, no new tooling, or no capital tells investment. Uh, we follow a design for system approach on this one. This will be the methodology that we will be using. So this start with a concept, uh, capture the customer and system requirements, identifying the critical to quality like accuracy, offset, bandwidth, temperature range, all these different critical to quality for the customer. We're identifying those. So for the portion of define, we're gonna be building all the parameters. That's the P diagram. We're gonna be doing boundary diagrams, performing like PFMEA on replacement risk, completing MSA's analysis on the current test system right now. And on the portion of the design development, we're gonna be selecting the candidate for the OPAN, building prototypes, PCBAs, tested across like the low and temperature condition. And we're gonna be developing a control plan for pilot run. So that's will be really critical. Specifically, this design development will be really critical to be able to meet the targets that we're expecting to. And the portion of verify, we're gonna be doing the pilot production run, validation versus baseline, capability reanalysis, releasing new documentation, and all these are gonna be ensured that is data-driven installation, not just a cost swap, because we need to make sure that the product is compliant with all the requirements that we have. Over here, we can see the schedule. So the project timeline follows the DFSS phases. We have in January concept and definition. That's what we were working on in January. We have the CTQ, QFD, boundary, and P diagrams. We were doing the PFMEA, MSA. So now in February, we were working on the design and development. So we have all pan selection, prototypes build, electrical and thermal testing, and prototype control plan. For March, we're gonna be doing more like verification. So we're gonna do some pilot production run, validation testing, capability versus target. And now in April, we're gonna be doing the production release, final qualification approval, documentation, compliance with different agencies, and production implementation. So what we're looking for, and start validating the savings that is going through and applied all the way. Okay, this is a low risk, high return behavior project. So we can see that over here, there is not a lot of impact in terms of cost, but we can see that we have material cost reduction, PCB redesign is not needed. We have a lot of savings. We don't need like new test equipment, no like tooling needed. So there's not too much cost involved in this. Mainly, we see more reduction than cost because all these products are mainly in-house. So equipment, test equipment, and tooling verification. Thanks for your attention, and let me know if you have any question on the comments.